Swayam Prabha. Digital India. Educated India.
In the last class we were discussing the various layout patterns of the main lines and the laterals, which depend on the topography which you are having in a specific area, and we had seen some of the layout patterns, how they can vary with respect to the availability of the source and with respect to the terrain which is prevalent in that particular area. We had discussed specifically those terrains which are quite regular terrains. They are not highly irregular. Let's have a look at what will happen when you have irregular terrain. In that case, when you have irregular terrain, what can be the possible layout patterns? Again, these are some of the possible layout patterns. There can be many others which can be used, and it will be a function of many factors. It will also depend on the choice of the operator or the designer. He can have 2 or 3 options, out of which you can choose one. Let's have a look at one such possible irregular terrain. Let's take this terrain which has more undulations. If we say that these are the contours, which in general might find, that means there are 2 ridges which are quite prevalent here. In this case, as we have, and in this particular case, the slope is in this direction. This is the general slope. That means these are the contours of higher elevation. These are the contours of relatively lower elevation. As we had earlier mentioned, that we will preferably have the main line on the ridge. Now, if we situate the main line on the ridge, and this main line, again the source, there are 2 main lines which you have laid. All these are the main line sections. This is the nomenclature which I am using for depicting the main line, as we have done earlier also. On these main lines, if you have laid the main line in such a fashion, to operate the laterals, the laterals can be operated in this manner, that you have these two laterals, this moving in this direction and this one moving in this direction. There can be another lateral, another set of laterals, one here, another here. This is moving in this direction and this is moving in this direction. This can be one possible way by which you can operate these laterals. This is the layout which can be used. Now in all these cases you can see, you can visualize that the laterals are on the minimum slope, the main lines are on the maximum slope, and the laterals are taking advantage of the fact that there can be some gain in pressure because of the natural slope which is becoming available to it. So it is compensating the losses to a certain extent. And then you are also trying to systematically move the laterals so that you can cover the whole area in a reasonably good time. But that is another part of the design, when you have to look at in overall sense how many laterals you will require to cover the whole area within the irrigation interval. Similarly, let us have another situation of irregular terrain. In this case you had quite a symmetric terrain. Let us take a case where you have a terrain which again you have these are the contours which are, again the slope is in this direction. These are the contours of higher elevation, and the slope is a downslope with respect to these contours. In this particular situation, you again, if you look at the situation, that in this case the slope is in this direction, the general slope, and as far as this part of the field is concerned, the second part of the right hand part or portion of the field is concerned, the slope is in this direction. So preferably you will like to have the main line laid on one side. I use the same color sequence for laying the main line. This is another main line which is laid down. Now from here I can have the lateral which is having the sprinkler heads, and that can be moved in this direction. Now the advantage is that in this particular case your main line is laid on one side, and you are still taking advantage of the fact that there is some downslope, there is some pressure recovery which is possible, and if your lateral is laid down in this particular manner, or is in this on this side. Whereas when you come to the other part, now this is the main line, which is you are getting the water from the main line. Suppose if you are getting the water from this end, now you are moved here, there is no problem because this is the lower elevation. When you move from this to this side, again the problem is not much because you are the increase in elevation is not very drastic, because this is the same contour, this is the next contour, and this is lower than this one. So you are almost going from a higher elevation to a lower elevation, and then again the elevation starts rising. But when you try to take care of this area, you might have to lay a main line which now will be going from this end to the upslope. Now this is the place, this is the point where you will have problem. You will have to have either a pressure which is very excessive. To take care of this this pressure requirement, you will have to have a pressure which is very excessive here, or you should go in for a booster here. You can have a booster pump here, and then that booster pump will provide the additional pressure which is required in this particular line. As far as the lateral is concerned, you can have the lateral which is taking care of the other half of the field, and this lateral you can move up. So this is one way of covering this area, in which you can instead of having a very high pressure in this section of the line, because in that case, as we had discussed earlier, if you have very excessive pressures, they might be detrimental as far as the pressure in these laterals are concerned. So either you will have to use some device by which you can control the pressure regulators have to be used, or you can go in for a booster, which is a much better option than providing excessive pressure and then bringing them down through the pressure regulators, because providing the pressure regulators increases the cost. Now with that, we have taken into consideration the various possible layouts, but that has not exhausted all the possibilities. There are many more which can be still used. They can be different than what we have discussed so far. Let's now try to go on to the main line. Mainline design. We have seen that the lateral, in the case of the lateral, we can, what we need is, we need to know that how much will be the loss. Then we can choose the lateral with respect to the pressure requirement of each individual sprinkler, and we have seen all those various requirements. But when we talk of a main line, again, the main line cannot be designed in isolation. The main line has to be designed with respect to the lateral pressures. What is the pressure requirements of the laterals? Because ultimately the main line, why you are providing the main line? To provide the water at a desirable pressure to the laterals. So if you say that this is the main line, this is the main line, and this is the lateral, we are interested in, when we look at the main line, what is the pressure requirement at the junction of the main line and the lateral? That is what we are basically interested in. So if we designate that pressure as HM, where HM is the required entrance pressure at main line in kilopascal. This HM can be expressed as HA plus 3 by 4 of HF plus HE plus HR into a factor converted into the kilopascals, and the various other items which we have expressed the HM in. HA is the design nozzle operating pressure, again in kilopascal. HF is the total friction head loss, which we have earlier computed. And the lateral, we have seen the various expressions by which we can find out the head loss in the lateral, where we had used that factor F. And this is expressed in meters. HE is the head loss due to the increase in elevation. Of lateral from inlet to the critical point. Or the critical sprinkler, you can say, in meters. And HR as the height of sprinkler riser. In meters. Now, in this particular case, you might wonder that why we have used this factor of 3 by 4. What happens is that if this is the total length of the lateral, you have the sprinkler heads which are spaced on this lateral. In normal practice, when we don't have these sprinklers, if there is a pipe, you can always say that the head loss and the total length of the pipe will be half in the first half of the pipe, and in the remaining half of the pipe it will be another half of the head loss will take place. Whereas in this case, since the discharge is varying, since the pressure is varying throughout the section of throughout the length of the lateral, the head loss, it has been seen that if you take this total length and the first half of the length of the lateral, 3/4 of the head loss will take place in the first half, and only 1/4 of the head loss will be taking place in the subsequent half of the pipe. So, when we are designing the HM, when we are designing the main line for the pressure, we are making an assumption that we are interested in designing for the average value. The pressure, the average pressure which is considered is somewhere in the midway portion of the lateral. So when we take the total lateral, we are only interested that the HA which is applicable, HA, is the average pressure and the total length of the lateral, and that's why we take this 3/4 as the portion of the head loss, because that is what occurs in the first half of the length of the lateral. Okay. Now, height of the sprinkler riser, there is a minimum sprinkler riser height which is recommended, which is a function which depends on the size of the pipe, the riser pipe diameter which is used. The minimum sprinkler riser height as a function of the riser pipe diameter, which is given in centimeters, and the minimum height is given also in centimeters. If the riser pipe diameter is 1.27 centimeters, the minimum height of the riser pipe should be 7.6 centimeters. Similarly, there are other recommended values which are given for the range of dias which are normally used. So these are the various values. Which are recommended values for the riser pipe height with respect to the diameter of the riser pipe used. Then, besides finding out what is the HM requirement, which is the pressure requirement at various individual points of the main line. On the main line again is the same thing. The main line is also behaving in a similar manner as the lateral is behaving. In the case of main line also, you might be finding that if you are operating more laterals, it will have a similar situation, that it is having discharge which is reducing as you go further into the along the length of the main line. But even if that is not true, one thing is certain, that when you are designing the main line, you have to look at the criticality of each individual point where you are tapping the main line by using a lateral. So the critical pressure requirement is very important to be looked at in a main line. Let us say this is the main line. You might be tapping this main line at various locations, and if this is the flow direction on the main line, let us assume that this is the last portion, the end of the main line. Now, when I want to look at what is the critical pressure in the main line, the best way is to start with the extreme point, because here we know what is the pressure requirement. HM is known, because HM has been found out from the pressure requirement of the individual sprinklers with respect to the other factors which are prevalent in a particular lateral. So if I know what is the pressure requirement here, you can find out, if you move to this section of the main line, what will be the additional pressure requirement, because it has overcome some more the friction friction of the main line pipe is one possible loss which has occurred in this particular zone, and there can be some elevation loss or gain. There can be some velocity head which is prevalent. All those things, if I say that this is N and this I call it I, to find out what is the pressure requirement at point I, the pressure head requirement if I call it HI, this can be put equal to Hn, which is the pressure requirement at point N, plus Hf In plus He In plus Hv In. What are these terms? Hi, we say, we have already mentioned that there is the pressure head requirement at point I, and this is expressed in meters. Hn is the pressure head required at point N. So is the pressure head requirement at point N, again expressed in meters. Hf In is the friction head loss. There will be some friction head loss between this section from I to N, expressed in meters, and He In is also the increase in elevation head from point I to N in meters. Similarly, the Hv In also is the increase in velocity head from I to point N, expressed in meters. Now, these are the possible variations, and once you find out what is the value of the pressure head at I, you can keep on doing this for each individual point along the main line, and the pressure which is the maximum, that will give you the most critical pressure which should be used or which should be looked at, which must be taken into account when you choose a main line. Now, besides that, you will also be interested in what is the pressure head requirement at the pump, what pump should be selected. So the pressure head required at the pump can also be, you can also evaluate with respect to the most critical point and the main line, and that also is theoretically I think is better to always find out for each individual point what is the total dynamic head which is required with respect to that point on the main line. If you can do that, then you'll be much safer, because there can be many situations where because of the increase or decrease in the elevation, you might find that the criticality of a particular point can vary. A point which you feel that should be critical, it might not be critical because of the fact that the way the main line is laid on the field in actual practice. So the total dynamic height requirement must be calculated for each individual point of the on the main line, and for finding out the total dynamic head of any individual point, you can use this expression which takes care of the various head losses prevalent, as we have seen in the previous case. Now, these are the various items or the terms which must be considered when we are looking at the total dynamic head required at point I. This is the total dynamic head required at point I in the main line, expressed in meters, and the HI we already know what we have already mentioned. The HI is the pressure at that particular location, plus HF dash PI is the friction between the friction head loss from pump to point I, expressed in meters again. And the other items are also similar. This is the elevation, increase in elevation head from the sump to the point I, or the level of the water source. HE SI is the increase in elevation head from level of water source to point I. And this HFS is the friction head loss on suction side of the pump, in meters. Now this total dynamic head should be computed for each individual point on the main line, and that head which is, or that total dynamic head which is the maximum, that should be selected for the selection of the pump. And at that time you can also make a decision whether to have a booster pump somewhere in the later portion. If the pump size is becoming too much, that will create a problem of having very excessive pressures in other points of the main line. So you have to look at which option to be selected. Do you want to select a pump which can cater to the problem or cater to the requirements of all the individual points, but then you have to look at how much is the fluctuation. If the fluctuation is very high, you might decide to use a booster pump instead and avoid using any control devices on the laterals. Okay. Now, with this, we have completed the detailed design of the sprinkler irrigation system. We have covered almost all the segments of at least one specific type of system where we are not is not a and there are many other types of sprinkler irrigation systems which we have discussed, but we have not gone into the details of the designs because of the paucity of time available with us. We have taken only the conventional sprinkler irrigation system, which is normally in most of the places is becoming more and more popular, and we have discussed almost all the various aspects of design, how we go about the design, and which are the various components which have to be looked at, what are the other details which are important to be considered. And with that we close this chapter. Any questions? Okay then.